Our hands perform thousands of complex tasks every day. Can artificial intelligence help robots match these extraordinary human appendages? Sarah de Lagarde was on top of the world after climbing Mount Kilimanjaro, but a month later, she found herself in a hospital bed with horrific injuries. Offered a prosthetic arm by the UK's National Health Service, she found it prioritized form over functionality, offering little in terms of normal hand movement. "It doesn't really look like a real arm," she says. "It was deemed creepy by my children." The prosthetic only featured a single joint at the elbow while the hand itself was a static mass on the end. For 9 months, she struggled to perform daily tasks, but then she was offered a battery-powered bionic arm utilizing artificial intelligence. This AI-powered arm anticipates her movements by detecting tiny electrical signals from her muscles. "Every time I make a movement it learns," de Lagarde says. "The machine learns to recognize the patterns and eventually it starts predicting my next move." Even picking up a pen involves seamless integration between body and brain, requiring refined motor control and sensory feedback. Advances in AI are ushering in a generation of machines that are getting close to matching human dexterity. Intelligent prostheses can anticipate and refine movement, and soft fruit-picking bots can delicately pluck strawberries without squishing them. Vision-guided robots can carefully extract nuclear waste from reactors, but can they ever compete with the human hand? I recently gave birth to my first child, and her small hand wrapped softly around my partner's forefinger, illustrating the sensitivity of our dexterity. Over the coming months, my daughter's vision and motor cortex will develop, giving her increasing control over her limbs. Much like a baby learning to use their hands, dexterous robots utilizing embodied AI follow a similar roadmap. Such robots must coexist with humans and learn to carry out physical tasks based on prior experience. Trial and error plays a big part in this process, reacting to their environment and fine-tuning their movements. Traditional AI handles information, while embodied AI perceives, understands, and reacts to the physical world, says Eric Jing-Du. Human sensory systems can detect minute changes and rapidly adapt to changes in tasks and environments. But this technology is still in its infancy, and reproducing dexterity at the same level as the human hand remains a formidable challenge. Each one of DEX-EE's 3 fingers contains fingertip sensors, providing real-time 3-dimensional data on their environment. The device can handle and manipulate delicate objects, even shaking hands, but it's just a research tool for now. Understanding how to perform such functions will be essential as robots become increasingly present alongside people. One research project involved a robot repeatedly punching human volunteers to learn the difference between painful and comfortable forces. Roboticists have long dreamed of automata with anthropomorphic dexterity to perform undesirable, dangerous, or repetitive tasks. Boston Dynamics' humanoid robot Atlas combines computer vision with reinforcement learning to perform complex tasks. But the skills required to perform many tasks in human-led sectors pose a particular challenge. Most robots are trained on specific tasks, struggling to adapt to new or unpredictable situations. Cambridge-based Dogtooth Technologies has created soft fruit-picking robots with highly dexterous arms and precision pincers. These robots use machine learning models to deploy skills that humans possess instinctively, like identifying the ripeness of berries. Robots capable of handling delicate tasks could provide an important boost to many industrial sectors. For de Lagarde, improvements in robotic hand dexterity have brought back abilities she thought she had lost, like pouring a glass of water and hugging her children.